If we look at the fundamental underlying problem, if you will, and it's age old, and it seems to it'll never go away, is design for manufacturability, DFM. The disconnect, if you will, between design. We have a slide showing design said, "Forgive them, they know not what they do," and that's one of the problems that with regard to designing something that we can't assemble, or well, we always find a way to do it, but it sure makes things difficult and challenging, things along those lines. And it's just one of several examples. So, the micro passives, and we were talking about the problems with PTCs and things like that. And it just gets more and more fun, more and more challenging. And again, design for manufacturability. I have to admit that some of the CAD people have made great leaps as far as trying to get closer and embracing the various idiosyncrasies, if you will, or the peculiarities of our processes. But there's still a gap. And it's still, I would say DFM is still one of the biggest, all-encompassing problems that we have in electronic assembly.
That's Phil Zarrow. He and Jim Hall are my guests today on Reliability Matters.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Welcome to another episode of Reliability Matters. I've known Phil Zarrow and Jim Hall for many years. Phil and Jim, and what they describe as their brothers, operate ITM Consulting, a consulting and advisory firm for the electronic assembly industry located in Springfield, Tennessee. Phil and Jim also produce a question and answer program, answering technical assembly-related questions in an equally valuable and humorous manner. As you'll hear, Phil and Jim, while taking their customers' problems seriously, don't take themselves too seriously, which is one of the things I love most about them. Welcome, Phil. Welcome, Jim, to Reliability Matters. Thanks for being my guests today.
Thanks for having us, Mike. It's a privilege and an honor, and a lot of fun being with you today.
Oh, good. Well, we'll try and make it even more fun. Phil, you're one of the founders of ITM Consulting. Tell me a little bit about your history before ITM.
Oh, let's see. Going back to the age of the dinosaurs, I initially worked after undergrad school. Initially worked in for a company in New Jersey that made infrared fusing equipment, because that's one of the ways we used to put that wonderful tin lead finish on boards way back then using infrared, and that was later replaced by other means. But I worked in equipment actually probably almost what used to be half of my career. Went from there. I worked a little bit in PC board fab. Got whiff of all those great chemicals, and then I basically settled into assembly. And so early on, I worked for a rep on the West Coast, repping things like Eubanks wire strippers, Heller lead forming, Hollis wave soldering. All these another semi-anachronisms. And I worked for Universal Instruments for a number of years. And while I was with Universal in the very late 70s, early 80s, I had the opportunity to work with one of the very first pick and place machines, at least Universal's. And so I always reflect back that I was fortunate enough to be in surface mount when it started arriving on the scene in the very late 70s, early 80s. Spent a little time with a test equipment company. Realized I really love assembly, and went back to assembly. I was with Exelon Micronetics for a number of years, and that was a pick-and-place manufacturer. Of course, Exelon's known for their drillers, but for a while they stuck their foot and God knows what else into surface mount. And I left there to join Vitronics as a product manager for Reflow, and did that for a number of years, and ultimately left to join a tier 2 at the time contract assembler called GSS Array, where I had the opportunity to work for a very, very dear friend, and probably the closest I've ever had to a mentor, the late, great Rich Freiberger, for a number of years. And after a few years with Array commuting to San Jose in Thailand, I left and started ITM Consulting. And
that would have been about 1993?
Yes, approximately then, yes.
So in 1993, you were part of the founding of ITM Consulting. What does ITM stand for, by the way?
That's one of the great mysteries. When we first started ITM, the company itself, my former partner Deborah Kopp, now Deborah Dresser, we were trying to come up with a name. We came up with all kinds of interesting things and trying to get it cleared through the state of New Hampshire. They were very, very skittish. So we tried different things, and we originally called it International Techno Marketing. Debbie was into techno music and techno marketing. We figured it had both the technical side and also some of the market related sides we did of things. And state of New Hampshire, oh, it sounds like technical marketing. We have a company by that name. So we're going through. Meanwhile, we're trying to start a company. We need to print up, business cards and fun stuff like that. And finally, I said, all right, what about the initials, ITM? Is that taken? They go, no. I go, good. We'll take ITM Consulting. So through the years, we've joked about what ITM stands for. In the money, and not quite. Is today Monday, or it's Thursday, man? So so it's.
I love it. I love it.
But I'm happy to say it doesn't have the initials of any of us. So
that's funny. I guess just as well she was into techno music. If she was into hip hop, that would be a very interesting name, or country, or something like that, right?
You're right. Yeah, boy, I never reflected on that. So boy, that's bizarre.
So what was the inspiration behind leaving this? The supposed safety and security of a quote unquote real job where paychecks just come from heaven every week, and jumping off that cliff and getting into your own business without the perceived security of a 8 to 5 job.
Probably a touch of insanity, but that never stopped me before. As Jim can definitely relate. I don't know, but at the time, I think what was driving me then, it seemed like a good idea at the time. But I think looking in the rearview mirror and looking in the present, I would say that one of the things I like the most is the autonomy and the variety, and the variety of applications that we deal with, the problems we're doing, the challenge of troubleshooting, or what we officially call process failure analysis. But how do we do this? How do we solve this? Helping people, and the idea of helping people, setting up lines, diagnosing their lines, troubleshooting, fun stuff like that. So, but I would say it really comes down to the variety, and the autonomy is really good too. I mean, you give up something. I could have made a lot more money, I think, getting into an area like IT or real estate, maybe, and other things like that. But the autonomy is great. I find even sometimes that when I'm on site for like 4 or 5 days, after a while, I feel a little, one particular company, I feel a little bit of cabin fever starting to creep in. But yeah, it works out well, and it's just I enjoy it, and just found I have a real passion for doing it, as do my brothers who I work with.
Very good. Now, Jim Hall, you joined ITM Consulting in 1999, last century. What's your background, and how did you end up at ITM?
Okay, Mike, I'm a mechanical engineer by training, and I worked initially in the chemical process industry, and then I went into the solar industry during the energy crisis of the late 70s. And after that, I went to work primarily to go to work with a former boss, a guy I worked with in the solar industry named Doug Peck, who was engineering manager at that time for a heat transfer company called HTC, which made this unusual heating method called vapor phase. And when I initially joined, we, again, as an equipment designer and applications person, when I first joined, vapor phase was used for a lot of different things, curing epoxies, fusing coatings, and also this other thing called reflow of surface mount components. This was about 1980. 81 or 82, Don Spigarelli, the owner and founder of HTC, and I think one of the greatest entrepreneurs of our industry, looked at the world and said, reflow soldering is the horse to ride. It's going to be great, it's going to be big, and we're going to be a part of it. So we became a reflow company, and that at that time, the electronics world was principally through hole. People were vertically integrated, and they used their parts. All their products were through hole, and so we had to teach be able to teach the whole surface mount process. We set up one of the first labs to demonstrate it, where people could come in and screen print some paste, and we were using screens back then, and place some components, reflow them, and look at them under microscope and get a feel for this. And I was just, I'll be perfectly honest, Mike, I was in the right place at the right time. And I became both, again, an equipment designer and advanced application specialist, where we were working continually with the latest and greatest products that would come into our lab to see if we could reflow them. And I stayed with equipment companies. Of course, HTC was bought by Dynapert, which made insertion and pick and place equipment.
Right.
And then I went to work for Vitronics, and that's where I actually worked with Phil for a few years. And then we merged with Soltech. And after a while, I decided I wanted to do something else. So I left there and got talking to Phil, and he offered me consulting work, and it's just worked out great since then.
Excellent. Has vapor phase made a comeback for surface mount reflow?
People would say that it never completely left. If you go into certain development labs and so forth, you would often find one little vapor phase system sitting in the corner for reflowing those really heavy assemblies that you just can't do in your convection machine. But yes, in terms of its popularity, I would say it has come back to particularly with lead-free, where the process window is somewhat smaller at peak temperatures. Vapor phase reflow offers you absolute maximum temperature control, or the reality that it's impossible to overheat something in a vapor phase system.
Right.
And that has advantages for particularly, as I said, those really heavy, massive assemblies that just stretch the limits of your convection machines.
Right. That's what I've heard. In this industry, things don't really go away. They just get parked on a shelf for a while, and then someone finds another application for them. That's been my experience anyway. So I
agree with that.
I love your company's tagline. It's very authentic. We don't tell you what you want to hear. We tell you what you need to know. So I guess there's no, quote, emperor's new clothes at your consulting firm. So how does one tell a paying customer that they are indeed naked, to continue that metaphor?
Well, besides prefacing it with that aforementioned tagline, well, we just break it. And I don't know. I a lot of times, sometimes what we have to say is not well received, or, whether they're going to follow our recommendations, they want to believe it or not, or in denial. But I think for the most part, generally they've been well received. I mean, you paid money, you have us come in, and, here's the way it is. And we try to be as objective as possible. And, but yeah, I think part of it is that we don't just tell you what you're doing right and what you're doing wrong, but every recommendation we make is exactly that. We tell you, okay, here is how you can mitigate this particular problem. So it's always on a positive up note, I guess you could say, in a sense that we are providing, here's the bad news, but here's the good news. There is a solution. This can be remedied. So I think that helps, the fact that it's not just we're going to come in and criticize you, and it's basically, yep, we can help you fix this, and there is light at the end of the tunnel, and it's hopefully not an oncoming train.
That's right.
It's the I think it starts before the actual recommendation. Phil has always had a philosophy with ITM that we are, even though we're an outside independent consultant coming into your facility or your operation, we are not the enemy. We are here to work with you, to help you. We're not here to criticize. And Phil starts this at the very beginning of every meeting we have with every client. And I think that in doing that, he establishes a baseline of a relationship with the company, so that when you get to those points, as you said, Mike, where, you got to make some tough observations, that we have a groundwork of trust established. And I think Phil has worked really hard, and he does it really well.
Yeah, I guess to quote the late Hunter S. Thompson, we always like to say, we're not like the others. We're your friends.
Yeah, there you go. So I've had the opportunity to work as an expert witness, which I think you guys probably have over your many
Yes.
years. I'm assuming.
Definitely.
One of the services that ITM offers just sounds fascinating to me. It's called process dispute mediation between OEMs and CMs, as well as between electronic assemblers and material and component suppliers. So you're really definitely jumping in the ring with between the bull and the matador. And we've been on one side or the other in the past with our customers. How does one stand on the 50-yard line with opposing teams running toward each other and survive? And it sounds like of your two customers, one will love you and the other won't. So how do you provide that service, and how do you speak authentically to both? Both, I assume, are paying you, or some variation of that.
Well, I'm, as you mentioned, an expert witness work. Unlike, with litigation, we're not we're not necessarily in an adversarial position with either party, and it's usually one party that brings us in because they're basically at a stalemate, or just the stuff's ridiculous, that just the bad circumstances. So basically, the ideas are basically very positive, like help us find a solution, help us find a middle ground. And there's been all kinds of interesting things over the years. I guess I can give you one example. I remember there was one case where I was working with a tier one, and they had a board with several BGAs on the board. And this was back in the tin lead days. And the original spec on the BGA by the component manufacturer said basically, do not exceed 235 degrees C. These guys said, okay, we're doing, tin lead, we're going up to get a peak up like about 218. Then the unit came down from the component company, don't exceed 220. Wow, this is getting a little close, but we're still okay. Then it came down a little bit later, do not exceed 210 degrees. I go, whoa, what do we do here? Because the minimum temperature we have to achieve for full liquidus of our 6337 was 210, as it said in the data sheet from the solder paste. So, what do you do? And here's a case. Meantime, the customer of my client, the contract assembler, the OEM, said, what are you doing to our boards? What are you toasting the components? So it was like, So, again, they needed somebody objective to come in and basically sort this out. We jumped in, and our approach was twofold. First of all, we got I called the solder company and said, really, all you guys are a little conservative. All we really need for 6337 is a peak full liquidus of 205. And they said, yeah, okay, good. So then we went on working on, achieving that as our, full liquidus. And in the meantime, I tried to make contact with the component company because I want to know where this number came from. And unlike dealing with solder companies and cleaning companies, dealing with component companies, Jim and I were saying, sometimes it's very challenging trying to find intelligent life forms. You have to really, really dig before you can find somebody who really understands what our assembly process is. And consequently, if you look at a data sheet for components, they're always telling you what the operating temperature is, but not necessarily the process temperature. In other words, what you can see when you're building. Now, a lot of these companies have gotten a lot better. This was a few years ago. So I finally found somebody who in Hong Kong who seemed to know what the assembly process entailed. And he started saying, well, Phil, in reflow. And I go, whoa. Stop the presses there, Fred. I have probably profiled more boards you'll ever see in your lifetime. So let's cut to the chase. Where did this number come from? Why did you keep lowering it? Did you pull it out of the air? Did you pull it out of a certain orifice? Where did this come from? He finally conceded to me that everything was fine and dandy when they were running 235. Then one of their customers reported the device was warping. So they kind of arbitrarily, let's drop 10 degrees out of it without really doing anything scientific. And all was calm again. And then somebody else reported warpage. So I don't even know if this was ever documented. And they finally got down to this unrealistic number. In the meantime, back at the ranch, and we don't even know how many people actually had warpage, with this device. It was very, very undocumented. Meanwhile, back at my customer, we were able to get, we had a really good 10 zone of them. We were able to get a gradient across this board from 205 to 209. So we got under the number, and customer was satisfied, and it was everybody lived happily after. But we've had other cases too where the proverbial contest between the component manufacturer and the user, or the user and customer, things like that. So yeah, we do things where we're validating processes and making sure there's a good documentation and good practices employed there.
But one thing underlying what Phil is saying is another one of our mottos, and we've taken from our good radio buddy Gene Shepard. In God we trust. All others bring data. And this is so important when you bring down, as Phil was talking with his company, on what data, on what facts did you base this change in temperature? On what data do you have available that's causing you to come to a conclusion? That can often be really helpful in calming things down, bringing out, getting people to think more objectively rather than emotionally, and ultimately to get to the real root cause of problems.
We could shoot the breeze all day and come up with anecdotes. One of these days we'll have to do that, maybe at one of the next shows across the street in a bar or something. There is one that I enjoy on our end. As you know, we make cleaning equipment, and we had a customer, a contract manufacturer working for the OEM, and the OEM said, thou shalt, here's your process, thou shalt use this particular defluxing chemical at 10%, and not 8 to 12%, not 10 to 15%, not 5 to 20%, 10% plus or minus 0. And each time they tested the bath for concentration, they use a refractometer, which is like a blood pressure cuff. It's very average. It's not overly accurate, but it's close enough. And so they would get a 9.9 or they would get a 10.2, and they would either add more concentrate or add more water every single cycle. And sometimes they would have to dump chemical to start over again because it was less than a point off. And I remember jumping in the middle into the bull ring, like you guys do, with meeting with the OEM and our customer and kind of negotiate. I asked him, where'd you come up with 10%? And he goes, I read it in an article.
Yes, there it is. Yes.
Yeah. And must be right.
The dreaded article
was on the internet. It must be true.
Exactly. So they read an article and they said, this article said they were running 10% and that gave good results. So they said, okay, it's going to be 10%. And they never thought of a range to give them a little bit of breathing room. So yeah, sometimes it's really good to have particularly third party, like you guys, third party neutral companies kind of jump in the middle and negotiate the fine points of that. I read that.
By the way, Mike, we have a term that we use for that particular syndrome where the person involved, the engineer or whatever they're calling themselves that day, has no real firsthand experience, and he got this information from the internet or from proceedings from some paper he read, or a vendor told him it was a good idea. We call them popular mechanics engineers.
There you go.
And and I attribute that formation of that term to our good friend Kim Highland. And we kind of came up with that years ago when we found that a lot of the companies, there was a perfect storm of things happening in the 2000s. We had two major recessions, 2001 and again 2008, where a lot of people left the field, and we had a lot, and that's where we really started heavily outsourcing. And one of the phenomena, that we observed, and discussing this with Kim, was that a lot of companies that used to manufacture in their own boards were now outsourcing. And in doing so, a lot of their engineers who had process, background and knowledge had left. And the people that came in had no idea what was going on, but they read a few books and, of course, the articles, and, of course, the internet came into play. And, that's where this term originated. They were basically popular mechanics engineers that did no real hands-on practical, but I read in the book. And we still see syndrome, just like in your case with regard to the chemical concentrations and stuff like that. We see it. Why using nitrogen to reflow? Well, I read an article, and who wrote the article? But it's that same thing. So sadly it's a popular syndrome here, but just sign of the times, Mike.
I'm going to ask you about maybe an overstated issue in our industry in just a few minutes. But before I get there, Dr. Ron Lasky, who joined ITM, I believe, in 2007, and Jim Hall are both Six Sigma Master Black Belts. For those listeners who aren't involved in quality, because there is a difference, of course, between quality and reliability. For those who aren't involved in quality, that's a familiar accolade. To those listeners who may be unfamiliar with Six Sigma or other quality standards, can you explain the basics of Six Sigma and the associated levels?
Sure, Mike. Six Lean. Well, we teach and offer Lean Six Sigma, which combines both the Lean principles and the Six Sigma principles. And it is, we feel, the latest and greatest continuous improvement program or philosophy or methodology, and which means that it does three things. If you adapt it, you continually critically observe what you're doing, always looking at what you're doing. And the big one, the second one, is you put metrics on it. You put numbers on that establish performance levels, quality, and so forth. That comes from the Six Sigma that when Motorola coined it in the name in the 80s. And that is, if you can't measure something, you can't put a number on it, you can't control it, and you can't optimize it. So you're observing everything you're doing. You're putting numbers on it that define quality and performance. And then using that data, you make continuous improvements based upon what's most cost effective and appropriate for your enterprise where at the particular point in time. And then drilling down from the Six Sigma, of course, is improving quality, reducing defects. And it approaches both the concepts of accuracy and repeatability. Adjusting your process, such as you said, Mike, the concentration, right? Keeping that concentration right at a target of 10, the average on 10, and then reducing the variation, the 9.9 to the 1.1, keeping that from getting to be 9.5 to 10.5, that kind of thing. So that's the Six Sigma part of it. And Lean is a very simple concept. It eliminates waste. I think Lean has become so popular because waste is an easy concept to understand. Everybody understands waste, and most people don't like it. Most people would like to work to eliminate waste. So we use those concepts to achieve continuous improvement throughout any organization, all parts of the organization. And we teach it and certify it based upon the martial arts things, yellow belts, green belts, black belts, and then master black belts and so forth.
I imagine after the last recession, a lot of people discovered Lean, maybe not the traditional sense of Lean, but certainly the concept of Lean, because Lean was even more valuable back in those days.
Well, I like to think if you talk to Toyota, who is the sort of the foundation of Lean, they'll tell you that it's always been applicable and it can always be used and should always be used. But yes, there is continuing interest in continuous improvement, Lean Six Sigma. Unfortunately, historically, for the past 30 years or more, continuous improvements such as Six Sigma and Lean have been successful, but not very sustainable. So a big thing we try to teach our aspiring practitioners is that you have to think not only of the immediate project, but of the long-term continuous improvement and building an infrastructure based upon continuously looking, continuously evaluating, that's always looking for an improvement, better productivity, less waste, higher profits, ultimately. And that is probably the biggest challenge. Many different philosophies out there of what really prevents these programs, which are usually initially successful when you implement them, but they seem to fade over time. And we work to try to help students think about that and prevent that.
One of the services your company offers is electronic assembly process certification. What's that about?
Well, one of the things we noticed is that there's a lot of gaps in the area. For example, if you go to the IPC, you can get wonderful training in the area of soldering, hand soldering, workmanship standards of 610, and different certifications that way. But that's great for the multitude of manual operations. But we wanted people to really understand and incorporate best practices into the actual assembly processes. And we found that not only was there there was some sundry training, but nothing really concentrated. So we developed the training for that, and we have all the different key areas of assembly. Printing, placement, reflow, cleaning, wave and selective soldering, and basically we teach the course, and then to be certified in it, we basically give an exam, and as we like to do, the tradition of Dr. Lasky, our exam is not multiple choice. It's you have to answer it. And the reason being is, as Dr. Lasky likes to say, you're on the factory floor, you have a question, you have a scenario happening in printing. God doesn't send down a billboard say choose A, B, C, or D. You better know what it is. And so that's our certified training. More importantly, what we do with our audits is we do process certification, and we actually own 2 patents on our methodology and both our auditing methodology and our certification. And this is where we go in and we do an audit, and which by the way, our process audit is part of the the key element of our process troubleshooting and other things. But this is for towards process improvement. We come in, and typically we have 3 levels of recommendations when we do a process audit, because we know there are people who assign numerical value and weights, and we've tried that. But our methodology is we have 3 levels of recommendations. Level 1, do this or die, as it's called, is basically this is definitely affecting your process, affecting your yields, things like that. You want to implement this, and it's going to rectify a lot of problems you're having, and really put you in better state. Level 2 recommendations are, what you're doing is getting you by, but level 2 is best practices. If you want to be world class, this is really what you should be doing. And finally, we have level 3, which is what we like to call science projects. That X-ray, you're doing okay with it now, but really based on what we see, you want to kind of look towards improving and getting a more recent vintage features and things like that. Or cleaning methodology you're using is good, but you really ought to look towards widening your scope there, doing it that way. So that's and then when they fulfill all the level 1 recommendations, we come back and do a follow-up audit, and if they indeed have fulfilled those and nothing else is degraded, we basically certify their process. And it's worked out pretty well. The customers who have it really like it. A lot of times they'll use it to show a third party, their customer, that they've achieved this certification. So it's something we find very fulfilling too, because we know it's in the name of, as Jim was saying, continuous improvement. They actually want to improve the process. They're not being passive and with what they have, but actually that spirit that Jim was talking about.
Mike, a classic example of a level 1, something that's going on that can and it might hurt you now, is insufficient control of moisture sensitive devices. This is we see this probably more prevalently in every place we go. There are holes in your program such that moisture sensitive components can possibly be overexposed in your factory operation, and you wouldn't know about it because of you're not monitoring them well, you're not keeping track of them well enough, or whatever it is. This would be a level 1 a recommendation that we said, you should fix this, because you don't know if you're sending out products that have IC components on them that maybe have been damaged due to moisture sensitivity during reflow.
Yeah, well, in our business, moisture is, for different reasons, a big issue, because moisture is one of the 3 ingredients to produce electrochemical migration. You either control the current, which is not really an option. You control the residues, which is an option, or you control the moisture. And one can control the moisture in their facility. Once it leaves the facility, it's kind of open warfare on the part. So speaking of process issues, one of my previous guests, Bob Willis, stated that voiding.
You listen to him.
We love Bob, even with that silly accent.
Even with, I think it's all fake, but that's another story. He sounds smarter with being British, right? So
exactly, yeah.
Right, yes.
So he stated, we were talking about voiding, and he stated that voiding can often be overstated. Let me play the clip and then have you guys respond. Here's Bob.
If we look at low standoff devices, I guess over the last sort of 5 to 10 years, QFNs, we've seen them being introduced on pretty much any products. They're produced in that style because they're cheap to produce. You can put lots of different functionality in them, and you can get pretty good yields. If we move and forget about voiding for a moment, which on many occasions it's just not relevant, because most of the people using these devices don't need the heat dissipation factors that they think they need. So everybody gets drawn into, we need 20%, we need 10%. I've worked in companies for a couple of days trying to solve a problem when I talked to the designer, it didn't matter. They didn't even need to have solder underneath this part. And I'm trying to solve voids for them. Absolutely crazy.
Well, I don't think anyone's suggesting that we don't put solder underneath parts. I think he's a little hyperbole there. But is there a point to that? Are some people chasing their tails trying to get better numbers on voiding than maybe are required?
Absolutely, Mike. We've run into the same thing. Again, this edict that's come down, the lower the voids you have, the better off it is. It's basically overkill. One of the deadly sins, which we've cataloged of electronic assembly, is you never do things for cosmetic reasons. Typically like touch up for cosmetic reasons, but you never do anything. And what we're finding is that what it is that bothers a lot of people about voids could be like cosmetic. Give you a great example. A few years ago, we're working with a customer, and their product was a power supply module that was actually as a daughter board type of thing incorporated on the circuit board of their customers. So you had this thing that was about maybe 2 inches square, and one of the devices on it was a QFN, or what we now call a BTC. And they were trying to get, I think originally they were getting about 50% void on the big ground pad down below. And the vice president of operations said, we've got to get below 30. And what we did was, I love the opportunity. It was a great opportunity. This is quite a few years ago, working with a customer, on void reduction, avoiding the void, which is, still, the battle cry of many. So anyway, we worked on this, and we were able to, we were trying different things, the solutions at the time, different, window painting and lower voiding fluxes and experimenting with preforms. In the meantime, we went to component engineering and said, what is the actual requirement for, voids? In other words, what's the maximum amount of voids we can take where if we get any more voiding, we're going to jeopardize heat transfer, which is the purpose there. And they said, oh, really, 40% is fine. And we actually got down, I think, to about 35%. And but the VP of Ops is still, hammering on this. And why? Why? Because we're more than ample. And he says, and this is great, Mike. He goes, well, what if the end user of this particular circuit board that our customer's doing happens to X-ray their board? And what if when he's X-raying, he happens to X-ray the module we built? What if when he X-rays the module we build on the board, he happens to see our QFN? And what if he sees that voided? Okay, what if? Right. Well, the answer is, so what? We met the specifications of the component manufacturer and the application. We've not allowed heat transfer. So what? But you see, that's again where people get caught up in cosmetics. And they're basically chasing their tail, killing themselves, whatever, as Bob was saying. We see that a lot. But again, one of the deadly sins is you never want to, pursue something like that for the sake of cosmetic reasons. Right. Easier said than done, of course.
Sure. Well, it doesn't help when people have X-ray machines that show you things that may not be harmful, but all of a sudden your attention's drawn to the image, and one thinks they have to fill those voids.
Mm-hmm. Now, I will add, there are applications where we need what we call near zero voiding. And, that's a real situation. And probably most predominant is the applications we work with in automotive lighting, LED lighting. And
any LED, to be that matter. LEDs are very critical to temperature, to heat dissipation. And so avoid a single, and in LED, although it doesn't generate much heat, it's generated at a very small point at the junction of the LED. And if you don't heat sink that point, that LED can easily overheat and reduce its long-term reliability.
Right. So avoiding important to some, not always to everybody. So let's talk a little bit about I know you guys teach workshops on a variety of subjects. One of the workshop bullet points caught my attention: the 7 deadly sins of SMT assembly. And you'd referred to a few moments ago the 10 deadly sins.
Yes.
We don't probably
Bill
have.
has expanded it to 10. That's important. If we work for Motorola, it would have to be 12. But fortunately, we don't work for Motorola.
Right. I'm sure pride and sloth and all those things are probably not part of it. But we don't have time to get into all 10. But what would be perhaps the top 3 deadly sins of the surface mount assembly industry?
Oh boy, where to begin?
Process.
Well, I aforementioned, doing something, and particularly touching up something for cosmetic reasons, where you risk doing further damage or harm to a particular situation by, again, for example, subjecting you to another thermal excursion or something like that. You can mess up a lot of stuff doing that.
Bill, I'm looking at the list now, and the one that jumps out is greed. Build it cheaper, faster, but not necessarily better.
One of the classic sins.
Yep.
I remember as a kid, my mom, when I was very young, she would cut my hair, and it'd be done, it'd be fine. And then she'd look at it more critically and go, it's a little shorter on the left, so I'll bring the right side up a little bit. And then she'd go back and realize she did it too much. And then next thing you know, I almost like Mohawk. So you're right. Once it's done, it's done. Changing small things or attempting to open up the patient again for something cosmetic is tempting fate for sure. Mm-hmm. So
Probably the third one, Mike, that comes to mind of the top 3 is probably kind of along the lines of what Jim was talking about earlier. Is I forget how we categorize this in the course, but the idea of not using continuous improvement, being in a reactive atmosphere as far as proactive. In other words, never time to do it right in the first place, but always time to do it over again. So I would have to list that one.
We classify that as waste on the list, Bill.
Yeah, that's one you don't read in the Bible. Waste. Yeah,
that's right. It's like
another one associated with that is ignorance. We've always done it that way.
Mm-hmm. Yeah.
Right. Trapped in the past. So, as consultants and engineers yourselves, are there any trends or directions our industry is going that would keep you up at night?
Sure. Smaller.
Miniaturization.
Closer together.
Yeah.
Just putting everything, you must know this, Mike, cleaning a simple component when it's packed in so densely that it's hard to get your cleaning fluids in there is just one of the symptoms of this continuing push towards ultra miniaturization, making everything smaller, putting it closer together. And it just affects everything. Certainly you will trying to clean around very small things, tightly packed, low clearance underneath, trying to pick up chip components on a pick and place machine that you can't even see with your naked eye. Think about loading a feeder, right, and finding and stripping the tape back to find the first pocket that has a component in it, except it's so small you can't see which pocket is empty and which has a component, in the small apertures in your placement machine, and the tiny features you have to look at in your inspection machines. That is just a continual one that's, just doesn't stop.
Yeah, in the cleaning world, and probably in other examples of electronic assembly, the closer things are together, the less tolerance for residue. The closer things are together, the less tolerance for heat. The closer things are together, et cetera, et cetera.
Tolerance for tools crashing into adjacent components when you try to work on them.
Right. So when we decrease the gap between cathodes and anodes and components, and we put all this power electronics so close together, we really are getting very close to the edge of the process envelope. There is no room for mistakes. When things were larger, when you could, metaphorically drive a Mack truck underneath components and between them, there was all sorts of room for contamination or other process errors because you had space. And now that space is gone. So the amount of edge of the envelope processes is greater. We're really, one wonders if we are exceeding the ability to actually use these components. When you look at bottom terminated components that have zero gap, we trap all sorts of things under there. We can't clean them because there's no gap, or we can't clean them well. So, we are really creating components and designs that really push the edge of manufacturability.
Go ahead, Jim. Yeah.
I just want one of the supporting driving factor is higher and higher frequencies, because then your surface, the crosstalk through these residues and other things becomes more and more critical.
And I just wanted to add, but if we look at the fundamental underlying problem, if you will, and it's age old, and it seems to it'll never go away, is design for manufacturability, DFM. The disconnect, if you will, between design. We have a slide showing design said, "Forgive them, they know not what they do," and that's one of the problems that with regard to designing something that we can't assemble, or we always find a way to do it, but it sure makes things difficult and challenging, things along those lines. And it's just one of several examples. So the micro passives and we're talking about the problems with PTCs and things like that. And it just gets more and more fun, more and more challenging. And again, design for manufacturability. I have to admit that some of the CAD people have made great leaps as far as trying to get closer and embracing the various idiosyncrasies, if you will, or the peculiarities of our processes. But there's still a gap, and it's still I would say DFM is still one of the biggest all-encompassing problems that we have in electronic assembly.
Right. My last question. You guys have a car talk style question and answer program. I've listened to Car Talk for years. I was sad to see it eventually go. But you guys have that style of a question and answer program that plays on the Circuit Insight website, circuitinsight.com. Do you have any memorable questions that actually made you laugh?
Yeah, most of them. I don't know. I'm just trying to think which one stands out, Jim.
Can I? Here's one for you, Mike. Can I use Windex to clean my circuit board?
Yeah, that's one of our favorites.
I love it.
Yeah, the answer being sure if you don't want to use the board again, But I would say just in some of the practices we see people using paper slicers for board singulation and all kinds of fun stuff out there. But actually, I have to say most of the questions we get are, at least the ones that we air, are very good questions. A lot of them are very insightful, and they reflect basically situations that a lot of people can relate to and chime in, and it just works. That's why one of the things we like to say whenever we're lecturing, or certainly board talk. So that's the thing, is a stupid question, except the one you don't ask. There's some weird ones, but that's stupid.
Another favorite of mine, Mike, was if I am repairing a board that has a silicone coating on it, can I, after I repair the board, can I cover the repaired section with an acrylic coating? And will there be a chemical interaction between the silicone and the acrylic? And the obvious question is, wait a minute, why was there silicone on there in the first place?
Right.
And what is the difference between acrylic and silicone? The primary thing, one of the primary uses of silicone, of course, is high temperatures. And acrylic would not be capable of protecting the board or withstanding high temperatures if you used it as a repair material.
Well, I guess better asked and answered than just done, right? One of my favorite anecdotes, if you ever want to have a good time, sit with a bunch of service engineers in a bar one night. and listen to stories. I'm sure you can tell your own. But this particular person worked for a company, this is many, many years ago, probably 30 years ago, that made a semi-automatic stencil printer. And it was completely pneumatic. And you just pushed a button and it moved the squeegee back and forth pneumatically. And they shipped it to a customer and they received a call. The customer was in a great deal of distress because water was leaking everywhere. And, you know, you can only imagine, you know, just keep going, connect the dots. The customer obviously connected the air line to a water line. And instead of all the whooshing noises that one would hear with air exhaust, that was all water coming out. So it probably ruined the machine. But at any rate, strange things do happen. And I appreciate your question and answer show, and I appreciate the style that the show's done in. You guys always make me laugh, even when answering serious questions. So I appreciate the work you guys do there.
Well,
Good.
I'd like to credit that to Phil, who is so committed to making us laugh and not taking ourselves too seriously.
Yeah, that was a great segue back to the beginning there, Mike. I like the way you did that. But you know, as Jim said, and all of our brothers at ITM, you know, Jim, myself, Ron Lasky, Joe Belmonte, and Bob Klenke, we all basically embrace that philosophy. Is you know, try to avoid people take themselves way too seriously, because we don't. And yeah, it's that should be in life as everything else. That, and the other thing is, the only absolute is that there are no absolutes. And you know, it just gets curiouser and more interesting as we progress down, you know, forward in assembly.
Hey guys, I really appreciate the time you've given me today. I appreciate the insight that you guys bring, and I always love to bump into you on various conferences and trade shows. Thanks so much for being part of this Reliability Matters podcast. And before I'll let you guys sign off, I haven't prepped you on this, but I'll let you guys sign off with the way you generally end your Circuit Insight Q&A sessions. Do you know what that is?
We sure do. Yeah, it's written on our thing. It's yeah, whatever you do, don't solder like my brother.
And don't solder like my brother.
There you go. I was hoping you'd say that. Very good. Thank you both very much. I really appreciate the time, and thanks for all the insight that you guys provide.
Mike, thank you so much.
Mike.
It was a real pleasure. We look forward to the next time. Thanks again, Mike. Keep up the great work.
Thank you. Well, that's another episode. Thanks for listening to Reliability Matters. If you like what you hear, please be sure to give us a like. Just click the like or heart button below. If there are any reliability-based questions you'd like to have answered or specific topics discussed, let me know. I can be reached at mike@mikekonrad.com. That's Konrad with a K. Don't miss another episode. Subscribe to Reliability Matters on iTunes or follow us on Spotify. You can also listen to us on iTunes, Spotify, aqueoustech.com, PCBchat.com, Spreaker.com, or our newest affiliate, Ascendo Reliability, on reliability.fm, a site dedicated to all things reliability. Once again, thanks for listening. We'll be back soon with another episode of Reliability Matters. In the meantime, keep doing it right.